report card presentation. These are the grades from that presentation. And as you can see, not much in the way of improvements. The Road River held steady, but both the South and the West River declined in water quality. Now, part of that is because we started a little bit later in 2020 than we have in prior years, which meant that the water had more time to warm up, which generally makes for worse water quality. We did stack up the data collected from the same window in 2019 as we were able to collect data in 2020, and saw slight declines along that way also. But these data and these scores and changes are the whole data set from what we collected in 2020. So a few things, pH went down across the board. There were some bad algae blooms at the beginning of our monitoring season in 2020 that we blame for that, because pH, as we'll discuss in a little bit later, can either drive the, or I'm sorry, an algal bloom can either drive the pH up or down depending on what phase of the bloom it is. Also, a caveat for our bacteria scores, they are somewhat off because the bacteria stations are driven by community involvement, and we only collect data at places where communities have asked us to. And understandably, the communications at the beginning of the year in 2020 got fractured in a few places, and not as many communities, and sometimes not the same communities, participated in our bacteria monitoring program. So there were a few different stations that we were taking bacteria at, which made those data not exactly apples to oranges or apples to apples with 2019. So anytime that we are interested in looking into what might be going on in the rivers, the first place we look is the watersheds. And here you can see visually how much larger the South River watershed is compared to the Road and West. And this table explains a little bit more about that. You can see the South has 36,000 plus total acres. That's more than twice what the Road and West put together are. The Road River has much more forests percentage-wise than the other two rivers do in their watersheds. The West has the lion's share of agriculture in terms of percentages, and then the South has more wetlands and more impervious surfaces than the other two. So the reason that we look first to the watersheds is because pollution of these rivers is a local problem. Our pollution isn't coming primarily from the Chesapeake, it's coming from our own watersheds. And you can see that in this picture, which shows the darker green dots out towards the mouths of the rivers with cleaner water. And then as you go further and further upstream, the tendency tends to be to light green, to yellow, to orange, and sometimes dark orange. So just for basics, for anybody who might be new to this stuff, in our rivers here in Anne Arundel County, we have three major pollutants. There's sediment, simple dirt that comes from construction sites. It comes from stream banks eroding. It comes from stormwater. And then nutrients, which is mainly fertilizer and sewage or manure, another kind of fertilizer in the agricultural setting. And then of course there's chemicals, the grab bag of all the other things that wash off in stormwater, because in our rivers here in Anne Arundel County, stormwater is indeed the main culprit for our pollution. So we also have filters that are naturally occurring in the environment that help us fight this. Trees and shrubs in the water, or in the watershed, help to stabilize soil, they help to prevent erosion, and of course they need nutrients to live, and so they keep those nutrients from entering the water and becoming available to algae. Wetlands and the wetland grasses and other plants in wetlands help do the same thing. Underwater grasses also take up nutrients, and as they grow and proliferate, they help to prevent erosion along the shoreline. And then finally, our favorite biofilter, oysters, which when algae is blooming, oysters are there as sort of the last line of defense to scoop them out of the water as they feed and help us to keep the kind of clarity that allows underwater grasses to survive and do their photosynthesis and keep oxygen in the water and make good habitat for all the critters that we know and love. So of the three rivers, the West River was the one that had the worst water quality in 2020. And as you can see here in the line graph on the right side of the screen, the clarity in the West River really dropped off in the fall. For a while there, it tracked pretty closely with the road, which is what you would expect. The two rivers share a mouth. They're similar in size. And for a while, their clarity was similar, but towards the end of September, the West River's water clarity really dropped off. If you look upstream in the West River, you see that Ford's Creek was the only dark orange station of our 43 stations. It had the worst water quality of all of them. And so anytime that we see sort of a weak link in the chain, so to speak, we focus our attention there. And we spent a lot of time over the winter wondering about Ford's Creek and trying to figure out what might have caused this diminished water quality there. So as I said before, the first thing we look at is the watersheds. And here you can see Smith, Johns, and Ford's Creek's watersheds. Ford's Creek is the watershed that looks kind of like New York State. And it has an elementary school in it, and it has this peninsula in the middle of it that we'll talk a little bit more about in a second. But the bottom line is it's not a big watershed. All of these three creeks have very small watersheds, which is helpful in the sense that it gives us a more focused area in which to advocate, in which to consider restoration possibilities, and to do the sort of education and outreach that we do that helps people become better stewards of their own land. This is a similar, same map basically, but also shows the green lines, which are sewer lines, and the sort of orange colored diamonds, which are stormwater outfalls. So this is the sort of investigation that we do to figure out where we might look first to figure out what the problem is. Now this one shows those black circles with red crosses in them, which are septic systems. And you can see the peninsula that divides Johns and Ford's Creek has a lot of septic systems there. And so septic systems are a fairly profound source of nutrient and also bacteria pollution in Anne Arundel County. And it seems at least feasible that that's part of our problem with Ford's Creek. This map shows the underlying soils in the area. And as you can see, almost the entirety of the Ford's Creek watershed has moderate to low infiltration capacity. And that low infiltration capacity means that stormwater does not get as much of a chance to infiltrate into the soil, get into the groundwater, cool off before it wells up again in any of the springs that feed the non-tidal streams in this area. So we looked at the fork in Ford's Creek, and you can see that with this arrow here, and thought maybe we could try and do a little experiment. This satellite view of the three creeks watersheds shows that at least with Johns and Ford's, there's a lot of agricultural land use in those watersheds. And Fords Creek is split where that little blue arrow is between forested and residential area and agricultural area. So we thought, what if we put a couple of water monitoring stations on the fork that drains the ag land use and the fork that drains the residential forested land use? So this is something we're going to be looking at a little more carefully this coming year to see whether the which one of those land uses might be more responsible. Now, as you recall from the septic system slide, if septics are the problem, neither of them are going, or the septics won't be captured in either of these two stream reaches because these are both upstream from that area. So if we find not a lot of pollution coming out of either of these stream reaches, or we find that they're roughly equivalent and fairly low, then that might redirect our focus towards the septic system problem as the solution to what's happening. So as I said, we're doing these investigations and we are always welcoming of anybody else's input and ideas, and certainly people's connections and expertise. If there are people watching this who know folks in the West River watershed who might be willing or interested to learn more about what's going on in the stream behind their house or at the edge of their pasture, we would love an introduction to be able to network our way into that area. As is probably no surprise, this past year has really diminished our ability to go gripping and grinning with folks face to face. And so hopefully that can resume relatively soon as people start getting their shots. But also any time that we can have a Zoom call or a phone call with somebody who's interested, we would love to have that. So another interesting feature of the data this year was the bottom temperatures of the rivers. As you can see here, the South River's bottom temperatures increased fairly significantly, while the Road and West River's bottom temperatures declined in water quality, which is to say they got warmer. The South River's bottom temperatures were cooler than they were in 2019. So the reason that we monitor bottom temperatures is because they change more slowly, and therefore they provide a better indicator of long-term health, whether you're talking about a season or a decade or many decades. The bottom temperature of the water column change is not as susceptible to one thunderstorm or one windy day. But on the other hand, surface temperatures can tell you a lot about acute problems and explain fish kills and algal blooms a lot better to you. So that's why we take temperature from top to bottom. But at any rate, in the entire mid-Atlantic, the month of July in 2020 was the hottest in over a century and a half. So we had a really hot middle of the summer, and that definitely impacted the temperatures in the rivers. But why might it not impact them all equally? This bar graph shows that the West River's bottom temperature was well above the threshold. That 77 on the left is Fahrenheit degrees. The Road came in just a hair under that. The South River, half a degree, not a whole lot, but they were much closer in terms of their surface temperatures. And that makes sense because of the hot air that was impacting the water temperatures. But if you see this map on the right, this is a map that was generated with the use of a navigation app called Navionics, and the white is deeper waters. And you can see that the deeper water extends much further up the South River than it does into the west, and it doesn't extend at all into the Road. The average channel depth in the South River is close to 20 feet, whereas in the Road and West Rivers, it is often as little as 6. So that deeper water stays out of the sun. It doesn't get as impacted from solar energy, and also is, deeper into the earth where you've got a steady 55 degrees. And so that's our thinking as to why the South was able to hold those lower temperatures in the deeper water. All three rivers also declined in bottom dissolved oxygen. And in the South River, that actually resulted in persistent dead zones throughout the summer. And the flip side of the temperature coin is deeper water tends to have more anoxia than shallower water, precisely because it doesn't have that kind of atmospheric mixing as often. And so all of the biological material from algae, from leaves and anything else that sinks down to the bottom has a kind of deeper hole to degrade in and to create anoxic conditions. This is a line graph showing the average dissolved oxygen at the bottom of the South River over the course of the monitoring season. And you can see here, the 3 milligrams per liter of oxygen threshold is where fish will tend to be very stressed, and depending on, if you get to 1.5 or 2 milligrams per liter, it can be acutely lethal situations. And you can see that highlighting shows the amount of time where much of the bottom of the river was unable to support fish. So one of the reasons that we think the South River had a little bit better temperature luck in 2020 as opposed to 2019 was this differentiation in the rainfall. You can see 2019 was a relatively dry year, but 2020 had a lot of rain. You remember the slide that showed the soil characteristics of the West River having not very much infiltration capacity? Well, contrarily, the South River, most of its soil in the watershed is high on the higher side of infiltration capacity. So more rainfall means more water sinking into the groundwater, which is then cooling off as it replenishes the water within the tidal reaches. This is a graph that shows that precipitation month by month and plots it against the orange line, which shows water clarity. So you can see that for the end of spring and the beginning of summer, the water clarity was relatively level. Then when there was a lot of rain in August, it dropped. And then as the rain tapered off and the temperatures cooled down, the clarity increased. The relationship is not as strong with dissolved oxygen. As you can see, it started high when we started monitoring in May, but as the temperatures increased, the dissolved oxygen diminished. That's because of a couple things. Warm water holds less oxygen. Oxygen's less soluble in warmer water, but also as the temperature increases, it allows algae to bloom more prolifically. And as they die off, their bodies are decomposed, and that takes out oxygen from the water column. But again, after August, things start to cool off and the DO started to increase. DO is dissolved oxygen. Sorry for the acronyms. One little tidbit that we are able to offer that we didn't with the original report card is the nutrient scores. As it happens, things held steady on the nutrient front. So that's at least not too bad, not good. C pluses and Cs are not awesome. But these data only became available since the report card was first published, because the Arundel Rivers Federation was not the only outfit whose monitoring program was hampered by the pandemic. Department of Natural Resources also had deployment difficulties, and those deployment difficulties resulted in delays in processing the data that they collect, but they've come out recently, and here are your nutrient scores. Now, this, of course, these are data that only come from 3 spots, 1 on each river. so the geographic dispersal is not as robust as it is in our program. But this is where we get our nutrient data from. So another bit of sad news from 2020 was the disappearance of the small bed of underwater grasses from the Road River. Now, we should qualify this with the grasses that are monitored that we present data on are the widgeon grass that lasts for a longer part of the summer and into the early fall. These totals, as the slide indicates, come from the Virginia Institute of Marine Science, which does an annual flyover of the bay. And so the data are collected from photographs from an airplane. They happen in late summer and early fall. By that time, a different species of grass, the horned pondweed, has died off. Right about now and until late May, early June, you'll be able to see horned pondweed out and about in many different places. Unfortunately, just due to logistical constraints, it's not the sort of thing that VIMS is able to monitor. We have in the past put out the call for volunteers to monitor this from their kayaks. It's a little bit less comprehensive of a program, but still very interesting to see. And we have found in years past when there might not be a lot of widgeon grass, that doesn't necessarily mean that the horned pondweed also is diminished. The two seem to enjoy different water quality characteristics. So another mystery that we have been noodling over as we've looked at the data is on the South River, there are 3 creeks, Warehouse and Almshouse on the southern shore and Gingerville Creek on the northern shore that had really low pH values over the course of the summer. And there are a few different things that we've been thinking about and researching that might explain that. And I'll get to that in a minute, but this graph shows just sort of how profoundly different the pH values in Warehouse Creek were versus the average of the entire South River. You can see Warehouse tracked fairly closely with the rest of the river from June and July, but then by August, the pH values had plummeted. Again, July was a remarkably hot month, and August was a fairly rainy month as far as the months of our monitoring season go. So the combination of increased temperature and increased stormwater runoff certainly plays a part here. That was bottom pH on that last slide, but surface pH showed a similar trend. And in fact, the water at the surface on Warehouse Creek was even more acidic than the water at the bottom of the water column by a factor of about half of a pH unit. So part of that has got to be biological decomposition. The process of eutrophication, where excessive nutrients cause algal blooms and then the algae die and their bodies are decomposed in the water, creates acidic conditions. It creates carbon dioxide, which is acidic, or which causes acidic conditions in water. It causes the release of methane, which also is acidic, and sulfides, which can all drive down pH towards the bottom. But of course, as I just showed on the last slide, the conditions on the surface were actually a little bit more acidic than the conditions at the bottom. So another theory, and it could be any combination of these, I don't mean to say that one cancels out the other, is that stormwater was bringing acids in, which would explain why the surface had more of it, because that's where the runoff hits first. It could be chemical contaminants. It could be more acidic rain from increased carbon dioxide in the atmosphere. Or it could be this theory 3 kind of tandem with theory 2. Some of the soils in the South River watershed are on the acidic side. So if there were a lot of soil erosion, then that could be bringing the pH down in these areas. In the case of Warehouse Creek, there was only one major land use change, which was the redevelopment of the gas station at the corner of Route 2 and Mayo Road. I didn't get any complaints about that one in terms of stormwater runoff, and usually people are happy to send those on to me if they're people that know that I'm there. So I'm not sure about that one. And of course, the other option is 2020 was a different year. People might have behaved differently and somehow caused a change to the pollutants in the watershed that could then run off into Warehouse Creek. So it's something that we're still looking at, and this week is when we started our monitoring season for 2021. We're certainly keeping a close eye on those creeks like Warehouse that had bad acidity, or fords down on the West River that had overall poor water quality, and going to make sure that we take good notes and keep an eye on those creeks a little bit more carefully in order to give them the attention that they clearly need. So we always are looking for volunteers to help us on the water, but if you're more of an indoorsy person, we do have the Watershed Advisory Committee. We meet every month, and this is the sort of, this is the Arundel Rivers Federation think tank, where we bounce ideas off of each other, we share contacts and connections, and try to strategize about how we can fix these problems that we identify through this monitoring program. Of course, we're also always welcoming of donations. The only way that we're able to do this is because of funding from our donors, and we are eternally grateful for being able to do that, because you can't protect a resource without knowing what is threatening that resource, and that sort of support is absolutely vital to our work. So now is the time that we can open things up to questions. Let me just allow people to unmute themselves, and there should be a couple in the chat also, but now you are able to unmute yourself. So if you would like to ask a question verbally, go ahead and fire it up and we'll have a conversation. While I am waiting for somebody to speak up, there are a couple in the chat. One is, what are your grades based on? Are they solely based on comparing to the previous year, or does it compare to some sort of standard of health? So thanks, Bridget, for that one. That's a good question. The grades are based on, well, let me divide that question up. There are standards that are set forth in the Code of Maryland regulations for things like temperature and dissolved oxygen. And then there are also methods that we use to calculate our raw data. And those methods are set forth in a document called the Mid-Atlantic Tributary Assessment Coalition's protocols. This is a document that was drafted specifically for the purpose of providing guidance to citizen science organizations like ours, that was drafted by a panel of a number of experts on water quality and science, including my predecessor as South River Keeper, and people from the Bay program and from the state's Department of Natural Resources, University of Maryland Center for Environmental Science. So they got together and created a sort of consensus model for how you sample, and then once you have your data, how you analyze those data. So my friend Adam says pH should fluctuate during the day. As plants photosynthesize, they release CO2, which forms carbonic acid. The planktonic algae are more common near the surface, hence lower pH at the surface. That's certainly true. When we're in the middle of an algae bloom, you're likely to see elevated pH at the surface. And then on the backside of the algal bloom as they have died off, the decomposition process will lower it. And that's an important point to underscore, actually. There is a threshold on the top and a threshold on the bottom for pH. So if things get too alkaline, that would be a fail, and that would average into the grade for pH the same way that as if things were too acidic would also be a fail. So in some circumstances, we have found pH values above 8.5 in the middle of an algal bloom at the surface, and that is more alkaline than the standards that are set up in COMAR. Oh, Nancy is reminding me that if you would like to volunteer with us, that you should email her. Her email address is nancy@arundelrivers.org. And a shout out to Josh and Sarah, two former Federation employees. I only saw first names, so I'm glad to see that it's you guys. So we have a question from, I'm not sure if it's Kel or Cell, CEL. Anyway, how many monitoring stations do you have on the West River? We have, let me see, 17 on the West River. Yeah.
Thanks.
Sure.
Hey, Jesse.
Hello. Hey, John, what's up?
Have you looked at temps at specific depths and compared those between the rivers instead of just bottom depth? But say looking at temps at 10 feet or 15 feet between the three rivers?
Well, we can't look at depths at 15 feet between the three rivers because the West and the Road don't have that kind of depth. But I mean, except maybe out at like the very mouth. The closest we could probably do getting a safe distance off of the bottom sediments would probably be closer to 1.5 meters, like 4.5 feet, honestly. Would
Jason, Jesse, we do the 1 meter down.
Yeah, well, so we do, we have a 1 meter depth that we also use to compare them with. That's still pretty close to the surface, you know, I mean, depending on how windy things get, you could have a 3-foot high wave out towards the mouth of all those rivers. So I guess the short answer to your question is kind of. We haven't really plumbed that specific water column depth comparison very much. There might be more that could be learned there. Of course, all of our raw data are available to anybody who wants to do any independent research. And we might look at that in the future if we continue to see such a stark difference between bottom temperatures. We might want to see where that changes. And you know, there's a stratification in water columns when there's enough depth called a pycnocline, where there's a very abrupt change of temperature, salinity, and dissolved oxygen. And in fact, I mentioned the MTAC, or the Maryland Tributary Assessment Coalition protocols that we use to analyze our data. They have different thresholds for above and below a pycnocline in terms of how much dissolved oxygen you need to have to constitute a pass. So when it's much deeper below a pycnocline, the threshold is lower because there's just less expectation that you'll have certain levels of dissolved oxygen. So it can go from a 5 to a 3, and especially deep waters, we don't have these here, it can be to a 1. So there's like a couple places in the South River where you get below like 25 feet where you might have those conditions, but not many.
Hi, Jesse. Mary Kafori.
Hi, Mary.
How are you?
I'm well. How are you?
I'm fine, thanks. A couple of questions related to water temperature and I guess also the critter count. Your diagram indicated the impact on fish with water temperature, particularly between June and the end of August. What about the shellfish like blue crabs and oysters? Are they as impacted by water temperature during the summer months? And part two of my question might be about variety of species. Sometimes we see horseshoe crabs around, and are horseshoe crabs in any way an indicator of health of the bay or the tributaries?
So the first question I'll take first, and different critters have different tolerance levels for anoxia or for oxygen levels. So your big finfish, the rockfish, the chain pickerel, carp, things like that, they like higher oxygen. So if they start swimming through an area that has less than 5 milligrams per liter of oxygen, they're going to try and find better places to breathe. Crabs are a little bit tougher down the spectrum. They can be comfortable in 3 milligrams per liter. And oysters are tougher still. They don't become really acutely stressed until you're getting into the 1.5, 2 level, but acute stress should be distinguished from chronic conditions. And for oysters, they can't swim away. So if you have chronically low oxygen, like in the 2 milligrams per liter and less, then that makes them, you know, they might be able to fight through it, but the next time dermo comes through one of their diseases, they're going to have less in reserve to fight it. When spawning season comes, they'll have a less fecund spawning season because they've devoted so much of their internal energy towards just being able to breathe. They can't have as prolific an egg set or a you know, a spat set.
Okay, what about temperature? What about temperature for those?
Temperature, temperature is a similar answer. You know, different critters have different thresholds. American eel are pretty dang tough. They can hang when the water is 85 degrees. But something like a sturgeon, not going to be coming anywhere around here. And rockfish too, they like much cooler water. And oysters, you know, oysters can be stressed pretty seriously by very high temperatures. Oysters will love it cold as you please. I mean, that's why the oyster harvesting season is the winter time. That's when they're kind of at their best. To then address that second point, we have not ever really considered horseshoe crabs as an indicator species. I know that there are folks out there who do study horseshoe crabs in particular very carefully. But as far as what their levels of tolerance for dissolved oxygen or temperature is, I can't tell you. I don't know.
Thank you.
Anybody else? Anything that's on your mind? Lay it on me.
I have a question.
I hear somebody faintly. Who's that?
That's Sarah.
Hey, Sarah.
Sorry. Hi. Sorry, my reception is cutting in and out, but I had a quick question concerning warehouse.
Yeah.
So did you have a chance, you may have already thought about this, but did you consider looking and comparing the pH to the dissolved oxygen levels at warehouse to kind of confirm or deny the algae bloom theory?
Yeah, so the question was, did we try comparing the dissolved oxygen levels with the pH levels for the same sampling days in order to you know, confirm or deny whether eutrophication was part of the problem? And the answer is yes and no. Dissolved oxygen levels, so yes, we did look at that, but it wasn't able to really confirm or deny it for us totally one way or another, because bottom DO in warehouse was very often depressed to the level that would indicate eutrophic conditions, but it wasn't always that way at the surface. And this, you know, Sarah, you'd understand, like, the mixing aspect of wind at the surface area, coupled with the fact that when you're in the middle of an algal bloom, those algae are photosynthesizing and pumping oxygen into the surface of the water, kind of confounded the results. So, you know, there were conditions at the bottom that said, yeah, you got eutrophication, but then at the same time, the DO was often fairly high at the surface, at the same time that the pH was even lower than it was at the bottom.
But
So-
also, Jesse, we had really bad algae blooms in the spring, and that's when the pH was high.
Yeah, so we had, I had emailed with our quality assurance officer, Wayne Martin, about this a bit. And, we basically agreed that it was the sort of thing that if you wanted an ironclad answer to exactly what was happening, we would kind of need to change our experimental design a little bit to focus on that particular relationship, which we're not really positioned well to do right now. I mean, the data can be analyzed and sliced and diced in different ways. We haven't gotten there yet, and we may, but we hadn't been able to analyze it in ways that we could really suss out exactly what the dynamic was, which is why we have these three theories that it could be a little bit of any of them.
Are the acidic conditions worrisome enough to warrant testing further upstream in areas that you think might be problematic?
That's a good question. I'm not exactly, I don't necessarily think so. We went back to 2019 and determined that those acidic conditions in Warehouse, Alms House, and Gingerville were not present in 2019. So we're cautiously hopeful that this is not an endemic problem that is, the sort of thing that would require us to, start targeting restoration efforts and things like that more so than usual in those areas. We're gonna, obviously, like I said, we're gonna be keeping an eye on it, and if it persists through 2021, then we might have to change our focus on how we address that issue. The main reason that acidity is such a problem is because it makes it harder for anything that uses calcium carbonate in its exoskeleton to grow. So everything from oysters down to small zooplankton at the bottom of the food chain can be harmed in their ability to grow if things are too acidic. There aren't any oysters in Warehouse Creek except for those that are grown by our intrepid oyster growers off of their piers. And that goes for Gingerville and Alms House as well. But that said, we don't want to see that kind of wildly fluctuating pH value, because the stable acidity is such a bedrock component to a healthy marine ecosystem. We are concerned about it for sure. Right now, we're kind of taking a wait and see approach to see whether it persists past the strange year where everything was weird for everybody.
Okay, well, thank you for answering the questions and inquiries, and looking forward to updates in the future.
Awesome. Thanks for tuning in. It's good to hear from you.
Too.
Sarah's now working on wildlife in Delaware. So,
Oh, Jesse, this is Lloyd Lewis. Can you hear me?
Yeah, Lloyd.
Yeah, I know you're aware that there have been some concerns about what might happen to what's called Pennington Pond, or Big Pond as it's labeled by the county. And you actually came out and visited with us and took a look at it. As you also know, they're going to make some significant changes to the shoreline structures just off Mayo Beach Park. They talked about that last night, and we're concerned about further silting in of the and flow restrictions in and out of the pond, reduced flushing, if you will.
Right.
Is there any chance you guys might want to consider adding that pond somehow or another to your sites for getting some baseline data? And my question is partly because when they make these significant changes and change the shoreline and change the sand transport pattern, and we see further degradation, at least we'll have a baseline to compare to.
Can boats get back there?
That's a bit of an issue. Kayaks, so, you know,
Right.
you could launch a floatable, but I don't think you're gonna get your, I don't think you're gonna get your river keeper boat in there, no.
Yeah, no, so that was kind of where I was gonna go with that question. I mean, it's certainly a great situation to be in where you have, you know, a baseline of data to compare against conditions after some sort of a project is put in. What I would say is, as far as sedimentation goes, apart from the Secchi disc that we put overboard to measure water clarity, we wouldn't really be able, our program as it is wouldn't capture that. There are other ways to do so, and the county would probably, I would assume, be amenable to something along the lines of like staking the channel and, you know, to a certain depth, and then you can measure if, you know, over the course of the next 2 years, what used to be 18 inches is only a foot. Okay, you're learning something. As far as the water chemistry, things like pH and dissolved oxygen, things like that, those could be potentially monitored from the bridge that goes over that little channel that,
Right.
you know, into the pond. It wouldn't really fit with our current monitoring program, but this is the sort of thing that I would really urge you and anyone else who has like a really localized issue like that they're interested in learning about to participate more in the Watershed Advisory Board, because we might be able to lend equipment or certainly provide guidance in terms of how to set up a monitoring thing. If, you know, if you who lives there are interested and you figure, hey, I take a walk over this area every day for my exercise anyway, it wouldn't hurt to drop a little gizmo in the water. That's the sort of thing that could be very useful in terms of the pre and post shoreline project, because, you know, we that have done shoreline restoration projects, we are very proud of the habitat creation, the marsh plantings and things like that. The change in what they call littoral drift of the sediments and sands along a shoreline when you change the configuration of that shoreline is something that is, you know, there's literature out there. There's certainly been, you know, good scientific studies of that phenomenon. It's not something that we do as part of the monitoring for our projects. It's not required by the permits from the Army Corps of Engineers and the Department of Environment, as far as I know. And so, but it doesn't mean that it's not interesting and not worth looking into. So that would be my suggestion, is if that's something that you want to continue the conversation about, tune into one of the Watershed Advisory things and we'll hash it out and talk about what we can do.
Okay, fine. Let me take it up with the local neighbors. It may be that we can get a cadre of people that live on the pond or around it or near it or are there a lot, as you say, and maybe hit you up for the loan of an instrument now and again or something like that. But let me bring it up to the locals and see whether or not there's enough interest to take the next step. And I like your idea about listening in on the Watershed Advisory. We'll try that as well.
Cool, great. Yeah, you know how to reach me.
Yeah, thanks a lot, Jeff.
Any other questions out there?
Yeah, this is Baird Strawn.
Hey, Baird.
First, my hat's off to you how you can be a river keeper and keep track of all this scientific information, run all these programs at the same time as for 3 watersheds is
Thank you.
more than I can explain. I wonder, I find it fascinating as you try to zero in on the causes of the problems to identify sort of where degradation comes from. And I wonder if you ever had a case where you saw an improvement in water quality somewhere and were able to attribute it to some measure that was taken.
That's an
Church
excellent
Creek with
question.
bacteria.
Yeah, we have, so once you get, so, you know, most of our restoration work is focused further up in the watershed than like right there at the tidal interface. We have some shoreline projects, of course, but my best case study in how the restoration work, how the monitoring work that I do can demonstrate the beneficial impact of the restoration work is a project at the Davidsonville Wildlife Sanctuary that is off of Beards Point Road in Davidsonville. And so we had pre-restoration data for 3 years at that site. And we monitored things like dissolved oxygen, bacteria, and stream stage, how high the water was in the non-tidal stream. And we built a project there, started it rather in 2017, and I think it finished in I'm sorry. Let me back up. We started a project there in 2014 and it was finished by 2017. And we saw the water level go down, notwithstanding the fact that rainfall increased over this time, which meant that the project was soaking in the stormwater as it's designed to do. And we saw the bacteria go way, way down also, which showed that first of all, you know, less flow means less bacteria, but also the biological processes of the plantings in the project were helping to create a more diverse ecosystem where the enterococci bacteria, which we were monitoring, which are present in the guts of warm-blooded animals, had more predation and were just less abundant, even accounting for you know, flow and concentration. So that project was a really good indicator. It showed that the flow was reduced and it showed that the bacteria were reduced. Unfortunately, we don't have a whole lot of other, you know, pre-restoration baseline data, but we do have for the Church Creek watershed, there's a lot of pre-restoration data from, so it's a multi-forked non-tidal watershed in Church Creek. And we have had monitoring going on kind of where they all come together right before the tidal interface for many years. And Sarah actually developed and administered this grant funding for an experiment that we did from 2017 to 2019 that showed in one of the branches, which was restored, which is behind the Annapolis Harbor Center, there was a 40% reduction in nitrite plus nitrate. So one of the forms of nitrogen that fuels algal blooms was almost cut in half after we built a project back there. And this is one that Nancy loves to talk about because there was some press, I don't remember who, that called it the impossible stream to restore. And you know, we're a stubborn bunch and we just decided to go ahead and do it anyway. And it was good to see that reduction. Now, we monitored a few different pollutants at during that project, and it was sort of a mixed result. There was good reduction of nitrate throughout most of the watershed, but phosphorus did not seem to be impacted that much, and sediment did not seem to be impacted that much. Other scholars have also studied that watershed over the time period that we've done restoration there. And we've had 3 major stream restoration projects in the Church Creek watershed The county has also done other work there, and we attempted to capture the impact of each of these varied projects. They're varied in size, they're varied in type, and they were varied in the time in which they went in. And so it was somewhat tricky to account for all those variables, but a lady from the University of Maryland Center for Environmental Science, Dr. Solange Filoso, recently published a paper that showed over the course of her data set, the BMPs put into the Church Creek watershed reduced total nitrogen again by 40%. So, you know, that is a fairly significant reduction for a watershed that is as heavily urbanized as the Church Creek watershed is. It is over 50% impervious surfaces, and so the stormwater pulsing through those systems is really, you know, a high intensity, you know, wavelength if you were to look at it on a line graph. And so being able to capture pollutant over many years, as important as nitrogen, you know, we'll chalk it up to a success.
Well, congratulations to you and all you stubborn folks there at Arundel Rivers.
Thank you. Anyone else? Going once? Going twice? Well, I think then, you know, if anybody has anything that they think of after the fact, you know how to reach me, jesse@arundelrivers.org. And please feel free to reach out with any questions that come up in your mind in the future. And please do consider being a part of one of our watershed advisory boards. It's a really great chance to have. Right now, we're doing it virtually just like this, but these sorts of conversations are the order of the hour for that. So if you are interested in, you know, hearing more of this sort of content, please tune into those. And thank you all for tuning in tonight and for your interest in our work and your support of our work. We appreciate it very deeply.